So to continue where we left off, now it's time to actually get started with the simulation and also the stuff that we want to pre-set up before the sim. So what I already talked about before is adding some additional forces for the disturbance and also modifying the water velocity that we have, which is basically the field that is disturbing our flip fluid before the stuff breaks through. And so we do want to have a bit more pre-roll than we had in our pillar simulation. So up here, let's just jump to the very top section. This is our scattering method that we had set up before. Not sure if you remember when we did this. I was talking about creating additional ways of doing this. And the other one is without running through this for each. We're just going to grab our geometry, scatter some points onto it on the static frame, and then use our same method that we had with our colliders here, which is using the prim intrinsic packed fold transform to transform these newly scattered points with that. And it's this super easy and quick method to have, if you don't have any deforming geometry, to have points follow an animation. So let's get rid of all this stuff above here, or let's just quickly think, just leave this time shift, the scatter, color based, that should all be fine. The only thing that the stuff that we don't need is here, this stuff that is made for the loop. Let's just get rid of that. Let's stop the calculation here. So let's drag this over. First, grab our ship geo. And what we want to do here is get rid of this blasting, so we don't need that. So first, freeze our frame. And then we want to put this into the center, so the rest position. Not sure why it's not showing the points here. So we have points. All right, so basically what we had here, the points were not showing up. Couldn't find out why. So I just figured it's probably the same as with the viewport. Sometimes it gets stuck. And so let's just create a new tab, and now we have our attributes here. So as we see, we set up the rest before moving it back to the animation, and so we can grab that, just drop down the wrangle here, super simple, and move this to the rest position. So our current position is equals to the rest position. So let's call this to rest. Now we can scatter our points. Just cancel this. Might be a bit too much for our ship here. So let's go down to 2000 or something. Maybe this is a bit more reasonable number. We're at 3.5 million points approximately. And if you remember here, we have our cull based on the facing direction and then deleting those points. And so we're now down to 2.5 million. Already got rid of 1 million points. And here we have our ID creation. Let's drag that up there. We do have our normals here. Now it's what we want to do is take the same transform that we have here and move this, our newly scattered points, to the animation. And so we don't have to scatter on every frame. Let's just hook that up there, wait for the calculation to finish, and now we should be able to scrub through this in almost real time. And we have quite a lot of points here moving through this. So to animation, just add a trail there to calculate the velocity. So compute velocity. Now we should have our velocity attribute. Very nice. And from there, what we have here is our color fade. And I think this was used for the whitewater here. So emit surface whitewater. And since our ship is pretty huge and there's going to be a lot of water lying on top of it, we only had this for the pillar because it was so thin and shooting through the surface. But this ship is going to carry up a lot of water. And so we can get rid of this entire thing. And we don't really need an additional source on top of the ship. So let's just get rid of this portion here, delete that part, and we're going to be using this now for our surface disturbance that we already set up with the pillar. And so let's hook this up to our call up facing, drag this up a bit. And one nice shortcut that you can use if you select your nodes, and then you go to either the top or the bottom, whatever you prefer, and then you hold down the A key and then drag to the bottom. It automatically aligns all your nodes. If you want to keep the spacing, you can hold, I think it's Control Shift A, Shift A, and then drag to the bottom. It will just make them in a straight line without changing the overall spacing. If you just hold down A, you can pull them all down and have them the exact same spacing. So this is super for aligning nodes, and this also works for sideways. So for example, if we just drop down a bunch of nulls here, and you have them aligned like this, and you want them in a straight line, you just select one of them where you want to align the others to, and then you drag either left or you drag to the right. Both works the same. And if you hold down Shift and A, it just aligns them basically on the axis and doesn't move them together to have an equal spacing. So just as a quick tip there for really quickly cleaning up your setup. Now we feed this into our facing direction here, where we just basically grab the top parts as we had before, and we want this to happen on our animation. And I think, let me check here in the, if we, we should also transform our normals, since I think these are staying the same. Yeah, they're still pointing straight up, although they should be angled. And so what we want to do here is v at normal times equals our transform, but we have to use the a matrix 3. So we'll just convert this to a matrix 3 and then transform. And now we get the correct angle, and that's what we want for our calculation. So if this is slanted, for example, too much, then we don't want to have it included in the up-facing directions. And another thing that we do want to add here is, since this is moving up and then down a bit, so if we look at the overall animation, just disable our normals view here. So we see this is coming up through the water surface, up, and then it's jumping down a bit. And so it's gonna dive through the water surface again. And so what we want to check is if this has gone above the water surface, then do not include that into the calculation again, so it does not constantly keep disturbing the water surface. And the way we do this is through a solver. So let's just drop down a sub solver and then jump inside here, go to the first frame, and so let's just drop down a quick wrangle and delete based on the position. So this is the first input, so the main input, which is going to be changing throughout. So it's always going to grab what is in that current frame. And so what we want to do here is just delete everything that is higher than a certain threshold. So if our vector at position.y, so if our y position is greater than a threshold that we provide, so threshold, then we want to remove that point. So remove point, first input, and the current point number it is iterating over. So let's activate this and set it to 0.1 or something. And now, probably if we go further, wonder if we can update this in the solver. But at some point, yeah, here you can see. Now it starts to remove those points. And so we do not want stuff that is above the surface to constantly keep disturbing. So only stuff that is coming from underneath. And so we remove that point, but we want to also, once it starts to dive back in, so the points that got removed, we don't want to have them added back in. And so the way we would do this, drop down another wrangle and check compare against the previous frame. So the main input is going to be the current one, and then we want to compare if that point that it has deleted previously, if that is in the sim again, and if so, we want to remove it. And so the way we do this is with the ID to point, which is basically like a find point attribute but just for the ID. So what it does is it finds based on the ID, which we have here. Since the point number is changing, we can't rely on the point number, so we have to use something that is consistent. So if it just checks if it can find the ID from the current stream in the previous one, and if it does, it returns the point number of that corresponds to that to the previous one. And so what we can do here is just say integer, since that's the point number that it's going to find, and then find ID, we'll call it, and then ID to point, and then first input. So we want to, that's the input that we want to search for, and the attribute is going to be ID. And now if this attribute, so the find ID, is equals to -1, it's looking for an ID and does not find it in the previous one, but it does exist on the main stream, then we want to remove that one because it has already been removed. So so if it's -1, which means it didn't find a corresponding point number, then remove that one. So remove point, and then from itself, and then the current point number it's iterating over. And now one thing that we do have to add here, because otherwise it's going to be deleting them straight away, is a switch. So on the first frame, compare against itself. So let's hook up that to the switch, and then there, and then grab our starting frame here, add that in here. And so if the current frame is equals to our start frame, then this will evaluate to true and basically take the first input, and so not delete any points but keep them all. And then afterwards we always have a previous frame, because on the first frame we do not have a previous frame. And then we can continue with our modification here. So let's just quickly rename this. This is going to be our remove height based, and then here check against prev and remove. So this is our out. And now if we go back, enable our simulation, quickly save the scene. And now if we start playing this, and as we can see here, it is removing the parts and also keeping the ones that it removed. And we'll see this once it comes through the surface. I'm not sure if I want to wait that long. So let's just have this continue for a bit. And now I think we're starting to get some parts that are moving up now, and then that would come down again, because we can already see this starting to rotate, and now it's getting quicker and quicker to iterate over, and now it's coming back down. And so now everything has left the surface, and now we shouldn't get any points back again. And let's see, just let this continue for a bit. All right, stop it here, and let's have a look. So we only have a very small patch that is left, and we'll see if we'll get rid of that one before as well. But I think yeah, and so we can see here it's coming through the surface, and then it would plunge back down again. So if we just compare with the input here, now you can see it's going below the surface, but it's not adding back those points, and so we're not going to have that disturbance anymore. All right, so now we will be adding a grid here again, and so we can see here the grid. It's not covering the entire range. This would be hooked up to the flat tank here, but since that is going to change, just for testing purposes, we're going to keep it to smaller regions. We don't want to rely on that all the time. And so what we can do there is grab a bound of our animation from different frames. So first let's just grab the bound here, and then from that we will create our grid. So let's just create a bound and then a time shift. This is going to be the first frame, so $F start for the first frame, and then the same for the last frame. and then we're going to get some frames in between. And the way we do that, we just copy this node, and we want to find out the length. That would be the last frame, so $f_end minus the first frame, which gives us the shot length, so 229, or the sim length rather, and then multiply this by the range that we want to have. So basically, if we multiply this by 0.5, we're going to get half of the range. By 2.5, we're going to get a quarter of the range. And so let's just multiply this by 2.5 right now. And then we will add all this to our first frame. So $f start. And so this is basically our start frame plus 1/4. And we'll do the same for the center and for the last quarter. So for center, it's going to be 0.5. And then for the last quarter, it's going to be 7.5. And now let's just merge all these together. Oops, grab them, merge. And here, create a bound of these. And to this bound, just to have everything safe in a safe area, we'll just add a padding of 3. And so let's copy this parameter, paste, relative reference, paste, relative reference, copy this entire one, and then paste the relative reference down here. And now we do have a bit of extension there. And to flatten all this, just quickly drop down a wrangle. And if our vector at y, so vector at position.y, is greater than 0, so basically everything that is above, we want to remove that. So greater than 0, remove 0, current input, and then the current point that it's iterating over, and then we just say v at p.y is equals to 0, just so we flatten this all out. And now we only have, we basically have like the bound, just the bottom part, moved to the 0 y position, which we could also hook up to our water level, but since this doesn't change, no need to do that here. So reset to water level, and just to get a bit of subdivisions here, just drop down a subdivide, go for 4 or something, it should be fine, gives us a nice grid there. And now we can go ahead and use this instead of our grid here. So let's hook this up here, and this coming in here, and we can get rid of our grid. And now we should be able to ray our geometry, which we have here, onto that grid. And now we can calculate the distance. So basically what we had before, so everything that is slower, and then we can have this deep effect. And so if we continue scrubbing, then at some point it's going to be through the water, and then it's going to be gone. And then we'll have the same thing for the beginning, but it didn't cache this in the solver. I mean, keep it in the memory. That's why we're not seeing it. And so we would have a slow ramp up. But what we do want to add here is the range. So how far deep it starts to affect this. And so here we're just going to go ahead and, I don't know, go for a higher value, so like 6 or something, and just go a bit higher in the color here. So towards the end we have a quicker fade off, and that should be it for this part here. In the signals removement, we do want to bump this up a bit, so the radius, since we don't have the similar distance from the points, because in the scatter in the beginning we did reduce the density overall, because this would have been just way too many points, and so we just have to increase this radius here. Let's just go a bit higher for 1.5 or something, That should be okay. Let's have a look at our color transfer here. Not much happening. Let's check our extrude volume here. And so let's take this, our grid, and extrude it down. And I think I was just testing this. But so let's just quickly see here. So we have our grid here, and what we can see here is we have like a bunch of points sitting on the edge, and these are causing some issues with the extrude. And this extrude, I think it was set to -2 and then 1 or something as direction. So let's just go for -6, just to have a bit deeper effect, since we also have the deep effect here to 6. And then just to fix these holes that we're getting here, this weird behavior, just drop down diffuse before, and then this should get rid of that. And then now we have a nice closed geometry. So extrude here, add a transform up, but we want to have this a bit higher up, and so I would just take the depth here, copy parameter, and then paste relative reference, and then this is going to be negative, so inverting that, +6, and then times 0.5. And now we should move it in the center, just so we get to the bottom some disturbance and to the top as well. Now let's scatter some points here, same as we had before, into this area, and then we're going to sample, basically do a color transfer. This is getting a bit heavy, and so that's why I would also want to cache this. And so let's just see if we can actually see this here. So let's go over here, and so we should have a transform. Just check that our points are deleted. So transfer color. Yeah, here we can see it. It's just getting covered by the other attributes that we have down there. Other points that have basically a value of 0. And so what I want to do is the remap color. I want to use the same ramp, but rather have this after the rasterization. So just remapping the density, which would result in the same, but since the rasterizing is going to be a bit heavy, I want to cache that, and then but still be able to remap that later. So I'll just get rid of this node here, and so we just have a standard 0 to 1 with no ramp. And then I think the resolution here, let's just keep it as is. Do a quick rasterize here and see where we are at. Yep, and that seems fine. And so now let's just drop down a RUP cacher again, cache this out. So we'll call this our sim, since we do have a simulation here, which is the solver that it has to run through, so we can't split this onto multiple machines. So we'll just call it sim ship water velocity. Hook this up here, and for now let's just cache 1 frame. So render current frame, save to disk, and wait for this to finish the calculation here. I hope it's not going to go through the entire simulation there. So the next thing that we wanted to do is change the density, so remap that so we get a more contrast type. So basically the denser areas are going to stay the same, and the lower it gets, the quicker it falls off. So we'll just do this through a volume wrangle. Drop that down and then connect that to the stream. And what we'll say here is the float attribute at density. So our density field, we want to modify it. We just want to run this through the ramp. So ch ramp, and then this, we'll just call this ramp. And then the attribute we want to use is density. And let's create the ramp. And so we can see here, if we just change this, we're cutting off basically the areas on the edge. And so what we want is something that is a bit cut off, and then have a bit of dip at the end here, like that. That should be fine. Yeah. So just getting more stronger the denser it is, and then have a softer, slow fall off towards the edges. So we'll just call this our remap density. And let's just quickly have a look at our velocities that we currently have. So a regular slice here, and then the velocity fields that we have. And so what we do want to add, since this is like, this worked quite well for our pillar where we had it just a small area, but since this is something very large that is going to get disturbed, we do want to add a bit of larger features to this. So we'll keep the regular volume velocity that we have here. We'll just create another one. But before, I think let's see if we can get a bit more detail out of this one, so that we'll also get more detail in the smaller areas. And so let's just try adding a bit more in there. Yeah, there we go. And that, I think, will help the small areas. So let's duplicate this node here, the volume velocity, and then let's just go ahead and swirl size, go something very big. Let's just switch this here so we can actually visualize this. Let's go for 1, maybe even higher, 2. Yeah, and now you can see like these bigger features here, and I think this will really help the overall simulation. And now there's a lot of different ways we can just combine these. The fastest, or one of the approaches, let's say this, not the fastest, but one of them will be just to blend those two. And so let's just hook them up with drop down the volume wrangle, and in here we're just gonna sample both of them. So first let's define our small scale and then our big one. So since this is a velocity field, let's say vector, so vector, and then that would be our small, which was equals to our first input. So we can just grab it from there, v add vel, and then we have our big, which is equals to, we're just going to volume sample this. So volume sample, and we want to use v since we want to sample a vector field from the second input. The field that we want to sample is vel, and we want to sample this at the current voxel position. And now we'll just set our velocity field to the mix of those two. So lerp the small and the big, and we will mix these with a threshold. So channel reference, and then just call this mix. And now we should be able to have a look at this here. So right now we're 0, so we're staying with the small. And if we set this, where is it here, to 1, we should get the big features. And if we just go half, we're basically blending them. And we could add them together, but that would just cause a doubling in the effect and the strength. So I'd rather just go and mix them. You can go ahead and just try different methods here if you like. One thing that I do want to do is add like a multiplier for the small and the big one, so that we can change that here. So let's just create a channel for mult small, and we'll do the same. So just select this here, and we have to add our multiplier there, and then we'll do the same here. Multiply that for the big field, and then just create these two. So the first, let's just set them back to 1, and maybe we can go a bit lower on our smaller ones, maybe 0.5 or something. Yeah, nice. So we do get like overall bigger shapes, but do have like some small stuff in there as well. All right, we'll just call this our mix velocity noise. And I think that should be it. So here we're just scaling basically based on our density field, which is important as well. I mean, we already have that in there. So if we disable that, we will have the full strength everywhere. But since we want to reduce that just to the areas that have a high density, we use our density multiplier. So we can call this multiply by density. Okay. And then, so this is for the water surface when the ship starts to move up. And what we want to add as well is something on the ship itself. And there's a lot of different methods that are used for this kind of effect. So you could either, I don't know, for example, create like an airfield or some additional pyro source that you emit from the surface of the ship, and then that falls down, and then you can add that to the simulation. There's a lot of different methods for this. The easiest and best to control, I think, is doing the same technique that we're doing here, just adding basically a field like this around the ship. So basically water that is living on or is sitting on the ship will get a bit of a disturbance that way. And so it's not going to be completely flat and just sit there. So let's go ahead and add that effect. So first, I think we're going to base this off of our initial scatter that we have here. Let's just wait for this to finish. And starting to get through the surface. That should be fine. So merge, and then we have to add in our guns as well, since here this is empty, and we do want to have a disturbance on water that is living there as well. So let's just grab our guns. So object merge and geo gun. And oops, seems like we didn't cache that yet. Let me check. Yeah. So let's go ahead and cache this. So if we hit reload here, we should be getting, yes, there we go, our guns here. And so we just want to add the same scatter. Let's just, I'll drag that here. Add that to our guns. Might be a bit high. Yeah, that should be fine. So just merge those two together. And now what we want to do is get back our color. And so let's grab the, get the node for the facing direction, which is, I believe, this node here. Let's just paste that over there. Have a look. Yeah, so now we're getting all the top facing parts here. And then want to utilize that. So what we're going to be doing is just we're going to take this and then rasterize this, create a volume as we did here, based off the color. So what we want to do is break this up a bit. So add a bit of noise, and I believe we had this here in the old stream where we were breaking up this on. So let me just quickly check here in one of our pillars. And if we go here, break up emission, I think this was the one. Let's just quickly grab that, just so we don't have to create everything over and over again. Stop the calculation there. Come on, jump inside. Add that node, break up emission, and now we do get it. Probably it's a bit too big, so let's go down there. Bit bigger. Guess something like this should work. Maybe a bit more. Come on, it's so slow. Not sure if this is because of the recording, but okay, well, I'll just leave it this way. And then, so next we just want to set our Rasterize Attributes. So just quickly drop down a wrangle here. And let's check here and just set our density. So f at density will be equals to our red color. So v at vector at color.x, and also set our velocity field v at vel is equals to our velocity. And now we can just rasterize this. So let's call this our raster, or init attributes, and then drop down a volume rasterize. And I believe we could volume rasterize and then hook this up. Oh wait, wrong node. Volume rasterize attributes. Hook this up. And then our voxel size, I think 0.75. Might be a bit too high, maybe 1.5 something. Let's just see. And then we'll copy this here and put that into our P scale and just multiply this a bit up. So 1.2, just so it's a bit larger. And the attributes that we want to rasterize is velocity. So first density, velocity, and that should be it, I think. And so let's check this out. Yeah, that should be enough for our resolution. Let's see what we got here. Yeah, that's fine. After the rasterize, let's just go ahead and cache this here. So the same as we did over here, where we just cached it and then afterwards did the modification. So let's call this our cache. What would this be? I don't know, air source or something. So basically the stuff that is in the air. And then let's just do current frame, save to disk, and then we can continue from there. All right, let's have a look. Reload. Should be already from disk, yeah. And now let's just quickly check over here what kind of resolution we have. 0.075. So I think, yeah, let's just resample this so we don't waste a ton of time trying to rasterize this with a higher resolution. So let's just go BDB resample, and then let's use an exact voxel size. So using voxel size and then 0.075. Let's see if there's any difference. Yeah, slightly in the banding, you can see it. And then let's just grab everything that we have here, probably with the bottom node as well. So let's just copy this, drop it over here, drag it down, and then add that in there. Now, first, let's just turn off the noise generation here and just have a look at our velocity field as is. So this is what it looks like. It's a bit high, I think. So I'm just going to slow this down so we kind of match the velocity that we have over there. So let's just drop down a volume wrangle and multiply the velocity. So probably guessed how that works. Vector at velocity field times equals channel mult. And let's see what we could go here for a value to kind of match the other. So is this actually changing anything? Yeah, it is. Because we have auto detect on here. So detect range. And now, oh yeah, and now you really can see it. Here we have like these really high velocity areas, and we want to get down to a normal range that it isn't peaking too much. Just makes it easier to control later. So we'll just call this our multiply velocity, and then we can continue with our noises. So let's just turn these on, see how this looks, and maybe we could just leave it as is, not spend too much time there. I think this looks fine. Let's just try this out, see if this works, and then if we need to, we can come back to this later. Now, the other thing that we have to add, or don't have to, but we should add is if we have a look at our water surface. So this would be, let me see where we can get a quick preview of this. So I guess here. Yeah. So we already can clearly see this here. This is underwater. This would start to disturb it underwater already. That could be an effect that you're after. But we already have our water disturbing. And so we don't want to have this underneath because this might cause some strange behaviors or weird issues. I mean, you'd have to go and try it out. So I think we're just going to cull it based off the height. So everything that is below the water surface is not going to contribute to our velocity modification there. So let's just go ahead, drop down another volume wrangle and multiply this based on a height. So let's create our float attribute height multiplier. That is equals to, and let's just quickly run this through a ramp. So we'll call the ramp. Very creative here. And then fit our y position. So vector at position.y between our min and the max that we want to grab. And then we'll remap that to 0 and 1. And let me see where we are. Yes. And now we'll just multiply our velocity and our density field by this. So v at vel times equals, and then just grab the height multiplier. And then f at density times equals our height multiplier. So now it's set to 0 because obviously there is nothing set up yet. So the min height, or let's rather go for the max height where we want to start to have full effect. And this would be, I don't know, I guess from probably like 3 meters or something, we want to have full effect. And we want to have it fade or start to kick in is like 30 centimeters above. Because if you remember before, the other field that we created here goes, I think, I don't know, to, I have to check that again, but it's also goes higher than the water surface as well. Just so we do have, once the ship starts to push through the surface, it starts to create like push up the water, and so it will be higher, and we want to have that encapsulated in there. And that's why we're just going to go a bit above the water surface. So everything that is above 0.3 or below 0.3 will have 0 effect, and then everything that is above will start to kick in here. Let's just quickly re-ramp this here. So go a bit lower here, and then something around here. And let's just select all of these. So select the first one and then hold down shift and click on the last one. Then you can select all of them and just change the interpolation here to base spline just to get a nice smooth curve there. Maybe go a bit higher on this one just so it doesn't cut off too much. Maybe a bit more on this. Yeah, and then that should be good. So we'll call this our height multiplier. And now if we have a look, rather there, now we can see our velocity only applies here to the top part. All right, this concludes this section here. Let's see if we go to a later frame somewhere around here. Okay, we don't, oh yeah, of course, because we didn't cache this here, but if we quickly hit save to disk here, let's wait for this to finish. Nice. We can see the effect here. So basically at the bottom, there's not much going on, and then the higher it gets, the more disturbance we're going to have on the surface. So a liquid that is living on top, so, and facing upwards. So it doesn't matter if it's on the side, for example, then it would start to get disturbed. All right. I think this is it. One thing that we have to do is add this basically inside our sim. So just align this node here, just to have everything nice and clean. And we will call this our I don't know, ship surface disturbance or something. just grab this node, jump inside our flip sim, first disable our simulation here, and then duplicate our advection. And let's point this to our newly created node there. So this is our surface disturbance, which I'm going to lower that a bit because we don't want to have it as strong. And not treat it as wind. Same for this one here. Don't want to have a wind treat it as wind, because otherwise we'll have like a kind of like a drag in there as well, and we just want the pure velocity field here as a force. And so for the bottom part, so the surface disturbance, we do want to have this a bit stronger than we had in our pillars. So we'll just go ahead and multiply this up. So it's just ×2, so we can see that this is different compared to our pillar sim. So we'll just call this add water velocity, and then we'll call this here our ship surface disturb. Oops. I got some nice typos here. So surface disturb, and oh yeah, and down here as well. So holy moly, velocity. There we go. Looks better. And I think that's it. Yeah, we already changed the resolution. Oh yeah, one really important part, of course, is the domain. We didn't really adjust that yet, so let's go ahead and do that right now. So for this size, I think we have to go a bit bigger here. Probably also for the position, we have to change that. So now I think from what I remember, the ship is coming up and then curving this way. So I think it's like where it comes up is here. Let's just add this to our visualizing. So where do we have it? Let's just add this here. Yep, and this is more towards the end already. Let's go to the beginning. Yeah, and this is where it comes up. So we do want to add here to that direction. Let's just go to the top view here, and maybe we can push it a bit back, a bit more, something like that. And then maybe, because I think it's also moving to the front, so just push this a bit further, maybe 1 meter or something. Yeah, somewhere around there. And then for the size, I think we can go a bit higher. So let's try like 50. I probably need more. 60. Probably it's not enough. 80 maybe. Let's see. Yeah. And I think that is because this is going to come up and then plunge down, and then it's going to create a lot of waves. And since the shot is quite long, or the sequence is quite long, we'll need the part up front here. And then for the size, let's go for 70. Hope we don't need that much in this direction. This is already adding up and getting slower and slower to calculate. I think that should be good, because there's going to be a lot of waves that are going to travel outward. And since there's also a top shot, if you remember from the animatic, we are going to see this part. Otherwise, I would move this back here. But we really have to be careful with our placement here, because just adding a bit or moving a bit really contributes to the simulation time. I think this should be fine. One thing that we do want to change here as well, maybe for the, because I think this is quite high, and I don't want stuff shooting up that far. So let's go for maybe a size of 30 or something. And then the other thing that we really do want to do is move this down, so have a much bigger depth. So let's go for 10 meters. Yeah. So this is where I want to start to have stuff getting pulled up, because I'm not sure if you remember, but when we were talking about the depth here, it's really important for how deep you make this, because this will allow the ship to carry and push up a lot of water. And due to the narrowband, it's only going to be adding the particles here on the top, but also it will still simulate in the bottom. So as soon as this starts to enter, the simulation area, then it will start to simulate the particles around the ship, and then this will heavily contribute to the overall look. So I remember when I was doing initial tests for like some breaching stuff a while ago, that was really changing the look of everything, is the depth of the simulation area. So from how deep under you start to push up. And so, for example, if you would have this really low, so like what we had before, 4.3 or something, you don't have that much where you can start to push through. Obviously, simulation time is going to be faster, but you don't have much volume to push up. So it's just going to be a bit of splashing, and the deeper you go, the more you're going to be pulling up, and it's really going to add to the sim and make this really look dramatic. I mean, it always depends what you're after. So I would also go ahead and try this, especially if you're using something different. So simulating a different ship, or have your own animation or whatever. I would definitely play around with this and see how deep you want to go until you get the result that you're after. So yeah, make this deeper. Don't want to go too high, because we just want to try to make this simulation as efficient as possible. So if there's stuff that does shoot above, it's probably just going to be some droplet stuff, some really small scale things, and we just don't care about that. So let's go to a later frame and have a look at this again. Yeah, and so I mean, if you look at it from a side view, like stuff that goes up here is fine here, and everything that goes beyond this, definitely we don't need that. Okay, let's see, anything else we want to set up here? Don't really think so. I think we have everything covered. The similar start frame should be fine. We have our surface disturbance. We have all our colliders in there. The resolution, we'll just keep it as is for now. So yeah, let's have a look, see how this turns out, and hope we didn't miss anything. Obviously, make sure to cache all this stuff here. So just create the dependencies in the SimNet here. I'm not going to go over that because you already know how to do that. And then cache all these that we have here, set up the correct dependency. Obviously make sure that these colliders are cached before you do this stuff here, because this is dependent on this. So for example, if you want to make this clear in your stream, then just take all this and move it above, so you know, or just hook it up correctly here in your SimNet, and then it will be obvious. So let's go ahead and sim this, and in the next section we're going to be going over the meshing process for this, which is going to be a bit different, I guess, because we're going to have a lot of big waves and stuff moving, way more than we had with the pillars, and we're going to have to deal with how to flatten the area outside and blend this nicely with everything that we have inside here, where there's a lot of stuff going on. So we'll take a look at that in the next section.